Right, we're trying to fit 7 different single-digit numbers in this diagram and work out which one must go in the question mark. So I'm going to write down my single-digit numbers. Now we only want to use 7 of them. We can rule out some of them straight away. For example, we can't put 0 in because if we put 0 in one of the rows or columns, or it has to go in a row, then that row will be product will be 0, but the other row won't be. So we can rule it out, and we can rule out 5 and 7 for similar reasons. If you get a multiple of 5 in this row, for example, there's no way you can get one in the second row because you have to times by 5. The same with 7, because these don't share factors with any of the other numbers. So we're going to have to use 1, 2, 3, 4, 6, 8, and 9. So I'm going to show you 2 approaches for getting the answer now. If I was to multiply all of these numbers together, then I would basically get this row times this row times the question mark. So it's worth just getting a feel for what that's going to be. Okay, we've got 2 to the power 1, 3, 4, 7 times 3 to the power 4. Okay, now note this row must be exactly the same as this row. So we're going to get a square number by timesing these two together, and then we're going to times by question mark. Now, if it was 9, if I put 9 here, for example, then I would still get 3 squared, but I'd get 2 to the 7. So I've got to have something involving 2, actually. This has to be a multiple of 2. Because otherwise, if it's not, then I've got 2 to the 7 when I times these two together, and there's no way that that can be a square number, which it has to be. So I can rule out 3. Actually, that's it at the moment. But then it can't be a multiple of 3. That's another way to think about it, because if it was a multiple of 3, if it's only, it'd have to be like 3 squared, but they're also with a multiple of 2, and 9 is the highest one. So I can rule out 6 because it can't be a multiple of 3. And then if it was 4, then when I remove it, let's say I put 4 in here, then the rest, these two would multiply to 2 to the 5 times 3 to the 4, which is not a square number, so it can't be 4 either. So it's got to be 8 or 2. That's what I'm trying to argue here. So let's look at the 2 different cases. Let's say it's 8. Then the other 2 rows would multiply to 2 to the 4 times 3 to the 4. So I don't know why I'm calling it the other rows. This is like it's almost like the magic number. It's the product of the 3 numbers squared, actually. So I would need to, this would be each row squared, and then I'd have to square root it, which would be, I can square them separately. So 2 squared times 3 squared, 36. Now the thing is, if each row multiplies to 36, and so does this column, and 36 is not a multiple of 8. So it cannot be 8, which means by process of elimination, it has to be 2. Now let's just try and finish it off and work out a possibility. So let's say it's 2, then the other 2 rows would multiply together to give 2 to the 6 times 3 to the 4. And when I square root this, I'm going to get 2 to the 3 times 3 squared. 8 times 9, 72. So we're saying this has to be 2, and then we've got to try and get 72 for each row. So let's just think about the rest of them. We've got 1, 3, 4, 6, 8, and 9. So to go with the 2, I need to get 36. So I could go maybe with 9 and 4. In fact, I think that's the only way that I can then get 36 using 2 as well. Okay, and then I want to get 72, so the 9 can go with the 8 and the 1. And then 4 times 18 is also 72. So obviously there's lots of different ways that I could arrange these, but that is a possible configuration that would work. So we've got the answer. I've argued why this is like using the actual official solutions. We've argued why we've got kind of the total number. We multiply them all. Said if we this must be it must be a square number when we times these two together. So if we divide by the question mark, we're going to get a square, which led us to say it has to either be 2 or 8. I've gone into some detail on that. Ruled out 8 because actually that would give us 36 for each row or column, and you can't get 36 if you've got an 8 here, so it has to be 2. That's the answer, and then I've just shown a configuration that works. Right, time for an alternative method. I'm going to pick it up with the same digits that we had. We'd ruled out 0, 5, and 7. And this time I'm going to label them A, B, C, D, E, F, G. Now, it must be that ABC is equal to DEF, which is equal to BEG. Now, from this, we see that AC must equal EG. These two must equal these two times together. But also, DF must equal BG. DF equals BG. Now, we've got a common factor of G. Sorry, not I don't want to call it a common factor, but G appears in both of these. So we need to look at our digits and think about how we can get some multiplications where the same thing appears twice. So we can only get 9 in one way. We can only but we need to think of some larger ones. So for example, 1 times 8 is equal to 2 times 4. We can get 8 in two different ways. And then another one is 18. 3 times 6 is equal to 9 times 2. And that is it, I think. Like that is the only kind of numbers that we can get in two different ways. 6 times 3, 9 times 2. As soon as you go any higher, it's not going to work. And what I noticed when I did this question is, hey, I've got this here, and I've just worked out this, and look, 2 is appearing in both, whereas all the rest are different. So surely G has got to be 2, and then can we make it work from there? So what I did then is I sort of just tried to fill it out. Um, so because I've got 3 times 6 and 9 times 2, maybe I put 3 and 6 here and make this 9. Then I've got my 18. And I've also got 2 times 4 is 1 times 8. So I put 1 and 8 here and 4 here. And again, it works. So this is, I think, less convincing. I think I could make a good argument for it, like explain why there's no other kind of it has to be G has to have this property, and 2 is the only number with this property. I suppose that is fair enough. I just don't think I've quite convinced you of that. Um, but I have ultimately found, for the purposes of this competition, I've actually found a configuration that works, so it's kind of got to be 2. The purposes of like a higher level competition where I had to justify why it's 2, of course, this first solution is a bit clearer. Like, we've explained why it has to be 2 or 8 down here, ruled out 8, and then, that can be the only option. Whereas here, I'd need to write a little bit more. In any case, like I've solved it. It's a pretty good question, and I hope you're happy.